It was not too blurry in the settings that I've chosen. Oh well, wanted everybody to be here live. Doesn't seem to be the case. All right, everybody can hear me, right?
Yes.
All right, good deal. All right, so what is a linked list? Well, I think you may have seen wish it would let me minimize. Since when am I unable to minimize? Oh well. A linked list is a data structure for storing data with more flexibility than an array. For example, let's go just take a picture of a linked list. A linked list is a series of objects where one object has a pointer to the next, right? And you can kind of...
Mr. Thompson, you aren't sharing your screen.
Well, that would be a problem. Why don't we share the screen as well?
All right.
All right, we should be good to go now. And that's why the other screen wasn't disappearing. Okay, so, no. All right, so a linked list looks like this. It's a series of objects that's got a piece of data, and a piece of data can be as simple as complex as needed. It could just be a number, right, or a string, or it could be a whole nother object. Doesn't much really matter. But it's a series of objects, which I'm going to now start calling nodes. It's got data in it, right? And then it's got a pointer to go to the next. So we're going to create a linked list that's not a proper linked list, right? We're just going to create a few nodes and set one to go to the next and set the next one to go to the next and so on. But the linked list itself actually needs to be a class. But I figure that if we demonstrate it this way at first, then it might make sense when we make it have a class, when we make it a class. All right. Then hopefully we can talk a little bit about inheritance as well. Hopefully you watched the video on it. I did get a few questions over that, so that's excellent. All right. So we're going to make a class called node, and all it is going to be contain an integer and then a pointer to another node, right? So class node. For now, we're going to make the data public and the pointer public. We might change our mind about that later, right? But I'm just going to call it a data int, right? Because it's an integer. I put that vice versa, didn't I? Let's put a colon in because that's necessary for C++ and not Java. Excuse me. Maybe we'll just initialize it to 0. And then we're going to create a pointer to ourselves called next, right? So that we can go from one to the next, right? So if we're sitting at this piece of data and we wonder what the second item in the linked list is, we can move to it, and then we can move to it again, and then we can move to it again, right? And there's several pictures here. You could also have a doubly linked list, right? With both a next and a previous. And that kind of makes some things easier to do. But then again, it makes the concept a little bit more complicated, right? Here's, don't know if I can get this picture to come up right. A singly linked list has data and then a node going to the next. And so each time we create a new node with the new command, we're going to set it as the element that's stored in the pointer of the last node that we created. And then a doubly linked list looks like that, right? Nodes going next and previous. And a circular linked list, I'm not sure why you do that. Once you hit the last one, it goes to the end. How do you know that you're at the last node of the list when you are traversing it? It's because this will be a null pointer. Let's do that. Let's play just a little bit before we start making a class called linked list, right? So we're going to make a node, right? Might be nice to make a constructor. We can make a constructor that would accept, you know, an int. But for now, let's just do this, right? Node star in equals new node, right? And then in arrow data underscore in equals like the number 10, right? Maybe we'll create some that say 10, 20, and 30. And like I said, this is not at all correct to be creating the node like this and then setting them up. Whoops, nade? Who's nade? Node, the way we're going to be doing, right? So in's next is pointer is going to be equal to this one right here, right? We just created a new pointer. And so we set the original ones equal to the next. And he needs a piece of data as well, right? Into arrow data underscore in equals 20, right? And then we set in2's next equal to, in's next equal to in2, like that. So now we have two nodes. We need a header node in order to keep track of where we are, right? And so our header pointer, right, or you could call it top or first, maybe just head. You set it equal to null to begin with because that indicates that there's no data. But then after you create your first node, you set the head equal to that, right? So the head is now equal to the first node. And maybe I should call this N1 rather than N, right? Because it's the first one. All right. Scroll up. All right. So we created a node, we gave it a piece of data, and we set the header equal to it, just like in the pictures. Just like in here, right? That, it now got a pointer to that. And the next of N1 has a pointer to N2. And N2 doesn't go anywhere, so its next pointer is still null. Now we're just going to make one more, and then we're going to write a loop that goes through it, right? So I'm going to make one more node. And N3's data is going to be 30. And N2's next are going to point to N3, right? Like that. So we created 3 nodes in a row with the header node pointing to the first one and each node after that pointing to the next one and the last node having a next of null because that is the default value. Oops, it is not. Look at that. I goofed on that. Null just means 0. It's a fancy way of saying the word 0. All right. So there we go, right? So this is the data of each node, and this is the pointer to the next node in the list. And we can set up a loop. Just a while loop would do. Good old simple while loops. So node, current is equal to the head. We're going to start at the top. Whoops, I didn't make it a pointer, so that's not going to work. There we go. So it's a pointer to the head. If we had not inserted anything into the linked list, then head would be null and we would be all done. So while the current is not equal to null, right? Then let's print out the piece of data current arrow data in, right? Guess I should have just called it data, and I meant to call it data int. Somewhere I lost my T, right? Followed by a \n or ENDL. That's not going to work, of course, because I forgot to put my using namespace up here at the top. Let's do that now. Why not include string on the off chance I need it? And then using namespace std. All right. So when it runs, hopefully it'll compile, hopefully it'll run. We should see an infinite loop because I made a mistake in my program. Let's increase the size of the font here so you can see it too. Those are a bunch of 10s, right? It's going to be an infinite loop because I never updated the next pointer, right? And so if your condition can never become false, it stays in an infinite loop. So let's go down and look at the while loop, and the next line of code after the print statement needs to be current is equal to current arrow next, right? So what was our current now becomes the next item, right? The first time through, current is equal to the address of this one, the one that head's pointing to. And then the next time through, current becomes that one, right? Because that's what the next pointer of that one is. And then the third time through, then it updates itself so that current is pointing to that one. So now it should print out. $10, $20, and $30. We're going to add a couple things to our printer. We're going to print out the pointers. All right, so it did print out 10, 20, and 30. Let's print out what the header value is, right? Cout linked list example \n, right? Yeah. All right, and then let's see out where the header is pointed to, right? Header equals, and point to the current, right? And then we're going to print out what the current is, right? Which will start off what the header is. And we did need an ENDL there. So we're going to change that to current. I hate to add too much to it. Maybe I should make this a separate loop because it was nice and clean the way it was before. I'm going to do that because in a nutshell, this is what we want, right? That's the absolute bare minimum if we get rid of the cout statements. But I forgot to print out the data, so let's leave that there. Okay, so that's what we had, but now we're going to do it again, right? So we need to reset our current pointer to point to the head, right? And there we go. So we're pointing to the head. We're going to print out the header pointer. We're going to print out the current pointer, followed by a space, followed by the data in. Let's run it like that to see how much more we want to add to it. All right, so the header, this is the memory address of the first object that was allocated. And then the current is set to that, and the value at that memory address is 10. So we want to print out the next as well. So why don't we print out the word data equals and then the word next equals, right? So this is going to say data equals, followed by the current data. And then we're going to print out the next equals, right? How about a space there to make it easy to read? All right. All right, that makes sense. We're starting at the top. We keep going while our current pointer is not null. We use that data right here, but we're just printing out extra information too. We're printing out our current memory address and the memory address of the next block, just to try to visualize it a little bit more. Right, and so the first object is pointed to by the header, right? And it points to the next object at that memory address. And at that memory address, its data is 20, and its next pointer contains the value CO8, so that it points to that one. And it has that object has a data of 30, and its next pointer is null, which is how it knows that it's at the end of the list, right? Okay, that's great and all that. But do you really want to create new objects and set old pointers and stuff like that like this? No, you want a class to handle that. Is there a way to dynamically declare the nodes? Yes, we were going to create a linked list class. And then when we want to insert a node, we will create an add method that inserts the node. So hi, Victor, glad to see you. And hi, Andrew, it was my fault for not being here. I had to log off and then immediately my router went down. It was very convenient. Okay, so if we were awesome, we'd put this in a file called node.h. I'm not gonna bother, right? So this class is gonna be called LList, right? And LList needs a head, right? Just like that. It doesn't need it to be public though, because main really shouldn't be able to monkey around with the internals of LList. So we're gonna leave this private. If you don't put an access word like public or private, it stays private. However, there's nothing wrong with putting the word private there anyways, right? Okay. And then that's just about enough. That's just about enough to get us going. So why is it wanting to tab here? All right, let's make maybe it'll stop tabbing when I type in public. I don't like it spacing on that. I'll live with it. All right, so the public is going to have an add method, right? Or we could make it return a pointer to the node if we wanted to, right? And it's going to take some data, whatever the data is. In this case, our data is an int, right? And so what's this going to do? It's going to make a new node. So let's make a pointer to a node. That thing is going to have the data that we passed in, right? Why don't we just change this? No, if I change this name here, I'm going to have to change it everywhere. So I'll do that in a minute. That's equal to the data that we pass in. The next node has already been set to null, but if we were paranoid and we didn't believe that, right, then we could set the next pointer equal to null, right, like that. And now each time we want to add a node, we just call .add and pass in a number, right? I'm going to do that. I'm going to highlight this and do rename and just call it data. I don't see why it needs to have that fancy name there when we can just call it data. No, I don't want to call it CZGZ. All right, there we go. All right, a little bit better. I really don't like it tabbed like that. Forgive me, Visual Studio. That's how classes should be tabbed. All right, so main, if it was going to run, should look like this, right? We need to create a linked list pointer. Maybe we just call it list, right? If it's a pointer to a list. Since it's a pointer, it needs an asterisk there. And then we could insert some items into it, right? plist.add, you know, let's add in a 5, and then a plist add in a 6, and then a plist add in a 7, right? Now we already have good code, right, for displaying the list. That for loop down there, it was pretty good code. So why don't I create a method? Oh, by the way, you don't have to put the word public in front of each definition like I'm doing there. You can just do it once until you need to change it. It's Java where you have to insert, you know, that keyword every single time. Otherwise, it looks very similar. You just type private space node equals and private void add equals. Slight syntax different. All right. So that's my linked list class. I'm going to go and purloin the while loop here. Or I could write it as a for loop. What would it look like as a for loop? Let's do that. Void print list, right? It needs a current header, right? So node star current is equal to our current head, this arrowhead, right? Oh, add is not done, right? Because nothing ever changed the header. After add, we need to update either our header or the value of the last one inserted. So we're actually not done, not nearly as done. I forgot add function needs to be a little bit better, because what do we need to do? If the head is null, then this object becomes the head, right? If it's not, we need to find the last object in the list, right? So let's define a one called current, right? And this is supposed to be an else statement because we don't need to find the last if we know we are the first. And this thing could be put into its own method if we think that we're going to be searching for the last element in multiple times. I think not. I think that this will be just fine to only put it in add. All right, so we start off there and we keep going while, again, right, while current is equal to null. But we also need a pointer to the last object, right? To the last one we were looking at. Because once we get to where current is equal to null, we don't know where we were anymore, right? We're sitting there looking in outer space and we don't know what we were standing on before, right? So this actually will be the first line. We're just going to set this equal to null first. And then inside the loop, we're going to say the last one is equal to the one that we're currently looking at, right? Last is equal to current, and then current is equal to current dot next, except greater than next. I'm glad it fixed it for me, right? So what are we doing here? Go to the last element of the list, right? That's what we're looking for. The last element of the list is the one where the .next pointer is null. I think there's another way to do that. I'm going to consider it and maybe make a change. Why don't we say while current.next equals null, and then we can get rid of that last pointer, right? We don't need to keep track of that anymore. Sorry, current arrow. There. This loop will step through the array, and when we find the last element is the one where current.next, current arrow next is null. Once we get there, we know that we need to update that, right? Current next value should not be null anymore. It should equal our current item, which is PN, right? So current.next equals PN. I'm going to clean this up by removing the braces. If there's only one line of code, we don't need that, right? And so next, last element's next pointer is set to the newly added object, right? Newly added node. Hope that makes sense. If head is equal to null, it means it's an empty list. If head is not equal to null, it's not an empty list, and we have to step through it. We're going to use a while loop like that. I am tempted to make this while loop its own separate method, but I don't see a good reason to do that. We can always come back and copy that, right? Put it in its own. Okay, so print list. It's going to be the same thing, right? While, well, almost the same thing, right? I guess we could do while current not equal to null. I'm tempted to try to write it as a do loop, but to do that, we would have to reject the case that the list is empty, right? We'd have to check if current is equal to null, then cout list is empty. Else, we could use our do loop. The only reason I'm doing it this way is to try to make it look a little bit more, no. I'm going to make it look exactly like it did down in main. So I don't mind having that if statement there, but it's still going to be a while current is equal to null list thing. I'm going to go and grab my print statements from down here. In fact, I could copy this whole thing. Don't, right? I mean, that was good code. Why not steal it? Come down here and paste it here. When we really wanted to print this out for reals, we wouldn't be printing out the pointers, right? We wouldn't be printing out P current and P next, right? But just for debug purposes, maybe we should call it print debug. And then make another one that prints it without the debug information, right? So this is the debug version of it, debug print. And the real printing is going to just be the exact same function, and I ought to actually get it working before I copy and paste it, right? So let's do that first. Let's do that first. So this is the end of our print method, right? End of debug print. Let's scroll down to main now and call that print function after we've added those pieces of data. So plist greater than debug print, or arrow debug print, right? Print out our list after we've added some things to it. And we could add some more values, right? plist add, 100, not with 3Ds, just 2. Add 200, and then print it one more time. Let's see if that works. All right, no, that's fine. Your question's fine, right? Dynamically declare the nodes because regardless of how it's set up, you'd still be limited by the number of declarations. And you're exactly right, right? You're exactly right, because setting it up like I was doing in main was the wrong way to do it. It was to try to get an example going that we could keep in our mind as we implement it as a list. So that's what we're doing now. All right, so here's our data. It seems like it's not printing out 6. Did I not insert a 5 and a 6 and a 7? And then did I not, why has it got a 5 and a 7 and now it's got a 5 and 100? It looks like it's only using one piece of data, right? It looks like it's got one node in it, and then that one node's next item goes straight to the end, like 6 got lost, and then that 50 got lost, right? And so our add code is not finding the right one to update. The one that we're updating is the next value of the first item. So we need to go and take a look. Maybe I should have written the add function the way that I was originally planning, right? No, that's the print statement. Let's go and find add. All right, going to rewrite it a little bit the way I was just about to do it, right? So, excuse me. So while current is not equal to null, right? While current is not equal to null, then our last pointer is going to point to our current object. Actually, we're going to set last equal to current, right? Because that's the first one we're looking at. And we've already ruled out the case where head is null, and so last and current could be null. Because that would be bad. If you try to write to null, then you're writing to an invalid memory address. Okay, and so while current, I didn't do that, did I? Did I have a single equal sign there? Isn't that like a super newbie mistake, using a single equal rather than a double equal? Well, I guess it is, but I'll finish rewriting it anyways. That was probably the problem. So current is equal to null. In that case, the last becomes current.next, right? And then when we find the last element, oops, there I go using that dot again. That's what I get for teaching Java. Alrighty, then the last element's next. I kind of like the way that this is set up better. I don't know why that's an error. Oh, because of that L there. All right. I like this syntax better. Whoops, that's not quite right though, right? Because the last is equal to the current that we're currently looking to, but now we're ready to jump to the next one, right? Current is equal to current.next. And the point of this one is to keep track of where we were so that when we step to the next one, we know where we were, because eventually we're going to get to the point where current is equal to null. And that's passing into the list, right? It's like going past the last house on the street. So we need some indicator of where we were before we take that step to go to the next house and we find ourselves past the end of the street. And Andrew, another thing that is correct is that at this point, it's not much better than an array, right? It's only got one advantage over an array currently. And what's that advantage? That advantage is that it can grow and shrink, right? When you declare an array of 10, it's 10, right? But a linked list starts off with nothing, and then you can append as many as you want to. That's the only current advantage. If we kept going with this example, we would make it so that we could insert into the middle of the list, and we could also delete items from the list. Now that's a lot more code. So I'm not sure I'm going to take it that far. But if you can visualize that, maybe I can find a little. Why don't I get this working before I draw pictures in the next one? Here I am eager to. All right. Now that I've got a double equal there rather than a single, I bet it works a lot better. See how that makes you feel better. Even professors make dumb mistakes. Not dumb, careless, right? And so it's still doing the same thing. That's a mystery to me. I had not planned on this messing up. So what we're going to do is in our loop, we're going to print out the current value. In fact, why don't we just stick these print statements from the print function, right? Right, I could just take this stuff and paste it into here, and we could watch it walk down the list, right? That's just for debug purposes, right? So let's just stick the word debug here. But let's go. Let's watch it go. Didn't I click go? What is there, syntax there? Nope. All right. I don't even see it printing any of this stuff, right? I don't see the word debug anywhere. I'm growing concerned. How's about, just to prove we're in here, I'm going to set a breakpoint here so that we can watch it add it. And maybe I should have added a cout statement saying, you know, that we're adding some data, right? Debug, adding, right? Followed by whatever data we're inserting. Just to make us feel comfortable that we really are stepping into this module. We know we are, but something's going wrong. It doesn't seem to be printing anything. All right, so I ran the debugger and it stopped here where it's creating the new node. Right now, data is equal to 5, right? I guess I should go down to main and make absolutely sure I'm adding 5, 6, and 7, but I think I have a good memory of doing that. Yep, there they are. So scrolling back up to here, la-di-da-di-da. As long as this mistake doesn't take too long to solve, I don't mind making a mistake because you get to see the process by which I am going through to try to track it. Okay, so our current node's data becomes data. And then we set our next node equal to null. And then debug adding, we should see that statement. Hope so. Yep, we're adding a 5. All well and good. So step over. The first time head is equal to null, right? Because we've never added any items. And so we're going to set our header node to our current node. I'm kind of not fond of PN as being the name of our node. Maybe I should have just called that node with a lowercase n. I'm not going to change it now, though. And so stepping over that, now we're returning from the function, and we're going to add a 6, right? So now we're back in the code. Step over it, data is equal to 6. We create a new node, we set our data equal to that. We print our debug, which is going to say adding a 6, right? All well and good. I did not mean to click that close X. Dadgummit. Yeah, great. Have to rerun it. I'll do it a little bit more quickly, though. It got to the first add, right? Data is equal to the add. See, I accidentally closed the window, so I'm running it again. But now I'm going to run it the second time. right? I'm going to let it continue rather than go step by step because I want to see what happens when it's at 6. 6 is malfunctioning. Okay, so now we're back in it and data is equal to 6. Let's step over. We create a new node. We set its data equal to 6. We set its next pointer to null. We print out our adding statement. Head better not be null anymore. Oh, it is, isn't it? I never updated head. No, I updated it here, right? But I didn't update it down here. Okay, no, I'm not supposed to update it there. Sorry, erase that last 20 seconds with a bad one. Alrighty, so step over that because that's not true. We're not at the first item anymore. So where are we? Current is equal to head. Last is equal to current. Step over. Go to the last item in the list. Is current equal to null? No, it better not because it's equal to the header element. And if we look down here, current is equal to, I know you can't see this, but the current item is the one that was 5. And since we added 5, 6, and 7, that's correct, right? It says data is equal to 5. It's got this pointer and it says data is equal to 5 and that the next one is null, right? So that null is correct. That header pointer is working and the first item in the list is working because it says 5 and null. Let's keep watching. Now, what in the world did it do there? It skipped all the rest of it. Hey, anybody spot what's wrong there? I want to go until I find an item that where I want to keep going while current is not equal to null. And what do I have there? Yep, it's not equal. Wow. Okay. But you saw how I use the debugger to do that. And that is really important stuff. I think I can get rid of these print statements now safely. One thing you can do that's cheating is to not only make a header, right, a head node in the class, but a tail node in the class, right? And the tail always points to the last one. And that way you don't have to use a for loop to find the last element in the list. I don't know. I don't see much of a reason to do that. I think we're good to go now. If we get this to work now, I may consider adding an insert, but I'll contemplate that. I think we could add an insert pretty easy. I need to remove that breakpoint though. All right, so I stopped it and I reran it. That's what I'm going to do now. All right, and so now we see it working. It's got too much output, right? But here we printed the linked list and its current data is 5, 6, and 7. I didn't know we added 100 anymore twice. I thought we added 100, 200, but I trust that that's correct. And then we print it out again and we see data 5, 6, 7, 100, 100. So let's make a cleaned up version of that print code, just called print rather than print list, right? Or debug print. And it doesn't need to have all that extra information in it, right? I don't mind that one though, right? I don't mind it saying that the list is empty. That's useful information. We don't need those braces, right? Except I guess we could have a return statement there if there's absolutely nothing else to do. I don't know. I'm just going to leave it empty. I'm just going to leave it like that. Alrighty. And then here, we don't need to print out the header, right? We don't need to print out the current. We don't need to print out the next. We do need to print out an ENDL there, right? There. So that's a little bit cleaner. All right, so let's change our print debug one to just print, right? We know that it worked. Now, so the second time I print it out, I'm just going to print it without its debug information. Or maybe, you know, print out a blank line and then call plist print, right? Like that. And then see out another blank line because now we've got more stuff coming up. Maybe since we know that this stuff works anymore and this is a too primitive way of doing it, maybe I'm going to comment all that out. All right, so I'm going to scroll back up and add a comment as to why that's commented out, right? The next batch of code showed how to add individual items and make a linked list by hand rather than use a class for it. It's okay for explaining, but not the right way, so we've commented it out. Alrighty. I want to see it print pretty, and then we'll move on to our next topic. Yeah, there's our linked list data, right? 5, 6, 7, 100, 100. And when we printed it out in debug mode, right? 5's next pointer is that one. 6's next pointer is that one. 7's next pointer is that one. 100's next pointer is that one. And the 100 again's next pointer is that one. How about inserting into it? What are you going to do if you're going to insert into it? Now I'm going to actually try the annotate tool. So I wish I was using a mouse rather than a laptop trackpad. But, all right, chat messages. Okay, you are correct. We are losing the value of that pointer because it's a local variable, right? And so it disappears. And so, yes, we were just assigning the same, Anna, we were just assigning the same value over and over and over because it said while current is equal to null. And current wasn't equal to null, so it just kept reassigning the same item, right? So, excellent that you see that. And what's going on here when we keep erasing and reusing that value there in our add code? Scroll back up to add. I'm gonna go steal my wife's mouse. Okay, right. We're losing that value, aren't we? We are, except we save it in the list itself, right? And so now we still have a reference to it. So we're good to go there, right? It's okay to lose the reference to our node as long as we have it stored somewhere in our list. And so either head's got to point to it or one of the nodes .next has to point to it. Hope that makes sense. Two more things we want to do is right now, once the list is deleted, it's going to have a memory leak, right? So if we call delete on this list, all those nodes we created are still going to be there. So we need a destructor to clean things up. Let's make a constructor first. Well, it can extend to as many as it needs to because each time we go, we're allocating a new node and then setting the next node of the prior last one to this one so that the last thing we just allocated becomes our current end of the list. Let me see if I can find an animation for it. Here's another thing that we should, we should find a good video for. But if I look up linked list append animation, maybe we'll find a good one. I really don't want to watch 3 minutes though. Okay, here we go. This looks pretty good. All right, so head, before they add anything, points to null. They don't show head as being a separate item, right? But head points to null, and then as soon as we create a new node, head now points to the address of this one. Okay, they're calling it start. Then they create a new item, and they're going to set null equal to, these numbers underneath are supposed to represent the pointers, right? So head now has 60. And then when we make a second item, PM is equal to new node, it has a memory address, and the next reference of the first item is going to point to that. Do I have volume turned down? I'm not hearing anything. Okay, it's quiet. That's all right. And so you see here that when the third item is allocated and it has a memory address of 525, it found the last one currently in the list and set its next pointer equal to the new item. And then the new item's next is set to null. Create another item, its memory address is 123. You see this temp pointer? They called it temp. I was calling it current. So to make our code look exactly like theirs, which I don't really care to, I would go in and I would rename this to be, what do they call it, start? Yeah, start, I would call it start. And then I would call the current node here temp instead, right? But whatever, right? Different name, same thing. Does that make sense? So it really can be infinitely long, well, until you run out of memory. So we're going to add a constructor. The constructor is not going to do anything, but I like to see a constructor there because I'm going to write a destructor as well. So what's a constructor? It's a public method. Has the same name as the class. It's got parentheses so that it can accept values, but we're not going to accept a value, right? When we create a list, it's empty, and we're not going to initialize it with one list element, although I suppose we could. And all it's going to do is set head equal to null. Even though we're doing that here, why not? Just to have something to do in our constructor. But our destructor looks like this. It starts with a squiggle, which is the key, you know, to the left of the one, you know, way up at the top. It's called a tilde. You probably know that. And what do we need to do? We need to have a while loop that deletes every element in the list, right? So that, because when we call delete on our list, it's going to leave all those items that were allocated because we never called delete on any of those. That's what we're going to do now. We're going to start at the top. This is going to look familiar, right? That's our current node. We're going to get our next node. So while current is, hey, I'm going to get it right this time, not equal to null, then the last item that we looked at is equal to current. We can delete that item. Whoops, I forgot to put the pointer nomenclature in front of it, right? And then we can delete that item, right? Delete that last item. But we better go to current is equal to current.next first, right? Because we better get the data out before we delete it. That makes sense? So if current is equal to null, it's because we never, whoops, we're supposed to set it equal to head. Forgot that, right? So we set current equal to head. If no items have ever been appended to it, then it's not going to go into the while loop. There's nothing to delete. You know, we could add some cout statements, right? list destructor. If current is equal to null, that means there's nothing in the list, right? Cout, no nodes in list to delete. course, in production code, you wouldn't add all these, but it's not bad to have it here just for our sake, right? Otherwise, we're going to delete it, right? You can even print it out first, right? Deleting node at last MDL, right? And so we'll see it delete each one as we go. It'd help if I spelled C out correctly. Now, I'm not calling delete on the linked list yet, so it's not going to do any of that. So I need to come down here, and after we've used our linked list, down in main, we're going to delete it, right? So we added all that data, we printed it out, and now we're going to delete it, right? So delete plist, right? Now, if we wanted to, we could make that destructor a method named clear, right? And then the destructor could just call that. That might be fun to do, right? So let's rename that destructor clear. So I'm going to scroll down here and call it clear, right? Doesn't need to return anything. And when it's done, it needs to set the head to null, right? Because now there's no items in the list. And the destructor is just going to call clear. So tilde L list just calls clear, right? That's all it has to do. I did add that delete command down in main, did I not? Let's go look. Down to main, down to main, down to main. Yes, I did, right there. Okay, so we're done with the list. We're going to delete it. Right. All right, and so it called the destructor, which deleted every one of these nodes, freeing up all the memory of all 5 nodes that we appended. And you do that to avoid memory leaks. Every point in your code where there's a new command, unless your program's just going to run and immediately exit, but if it's got loops, right? And if it runs until the user decides to exit it, then it needs to delete the elements that it has called new on as soon as they are no longer necessary. All right, gang, let's have a 5-minute break and we'll come back. I'm going to pause the recording and really hope that I remember to resume it. All right. I remember to resume it. So proud of myself. All righty. So if you were going to insert into a list, then what would need to happen? See if I can get annotate going. Say we wrote a delete function and the data that we wanted to delete was 525, right? Well, you have a while loop that keeps looping while the node's data is not equal to 525. So it starts at the head, right? And then the current node data, is it equal to 525? No, it's not. So we update ourselves so that our current node is this one. And is the data equal to 525? It sure is. So what do? We had one called last, or at least we better, right? We need to change that one to point to what he is pointing to, right? Because he is pointing here, but this one's going away. So his next pointer needs to go to here, and then we can delete him, right? Like that. And now we have a list just with 3 items rather than 4. All right, what if the one we wanted to delete was at the beginning, right? Oh, I said I was going to talk about insertion, but let's talk about deletion first, right? Because it's easier to visualize. All right, I'm going to clear that. Make a smaller line. All right, so we're looking for element 102. We set current equal to start, you know, and our last one pointing to the one before that, and then there is nothing pointing to before that. So is our current item 102? Yes, indeed, we found it, right? And so we need to set the item before it. Oh, the item before it, there is no item before it. So that is going to get set to 102, right? And then we delete this guy. What if we were trying to delete element number 42, right? We go into a while loop. Current is equal to a start, so 37, it's got a 525. Is that has that got a 42 in it? Nope. Is a 1 equal to 42? Nope. Go to the next one. Is a 42 equal to 42? Yes, indeed it is. So we got to set his next equal to his next. So we just copy that value straight into that, right? Like that. And then we call delete on that. Like that. I don't think that'll be too hard to write. Let's give that a shot. Would have been nice if it had deleted it. I thought I hit clear. Alrighty. There. Okay. Okay, so I guess we can call it remove, right? So like we're going to add the element 100, and then we're going to do plist remove element 7, right? Just for funsies. And then we're going to add 200. I don't like saying 100 twice in it, right? Okay, but we don't have a remove method, do we? Well, we're going to go add one. All right, so void remove, and it takes an integer as a piece of data, right? We're going to set our current equal to the header. Well, better declare it first. Node star current equal to the header. Except that's not what we call it, is it? We just call it head. We're going to create a last one, or one called prior, node asterisk prior, which is equal to null, right? And if it's still equal to null by the time we find our item, then we know we're at the beginning of the list, right? Because right now prior is nothing. We haven't looked at any elements yet. So while current is not equal to null, we're going to keep going, right? We're looking for the element that matches our data. So if the current node's data is equal to the data that we passed in, then we have found it, right? All right, let's think a little bit more about this. We can set our prior equal to the current one at this point. And if the current is equal to the data, we have found it, and we can just kind of break, right? Break out of our loop. I don't think we need to do that, though, until after we have established whether we found it or not. So we're not going to do that until after we decide not to break. And if we decide not to break, we're going to set prior equal to current and current equal to current next. Very similar, right? These loops tend to look a lot alike, but this one's going to break out early, right? It's going to break out when we find the right data. I think we may even need a reference like we had here when we were adding data to where we had one called last, the last one that we looked at. I'm not sure if prior will serve that one's purpose or not. If we get to the end of the list, if current is still equal to null, it means we never found it. Right, and we're done. Else we did find it. So now we have a couple of choices. What are our choices? We are the first item. How do we check that? If the current is equal to the head, that means that we're the first item. In that case, we will just set current head equal to current.next, right? And we can delete the current at that point. Else we're not the first item. That's the easy case, right? You just got to update your header and then you go. Okay. Else, the last one we looked at, his next needs to be set to the current guy's next, right? Because current is disappearing and we can delete the current. Sorry, it was called prior, was it not? Yeah. All righty. Yeah, because prior gets initialized to null. I guess that's the other way we could check, right? Instead of saying if current is equal to null, if prior is equal to null, either way would work. No, if current is equal to null means we did not find it. But if prior is equal to null, it means that it's sitting at the first item. So I don't know if that makes more sense to write it like this. If prior is equal to null, you could write it either way, right? Either one would tell us that we are the first item. Else, it's an item down the list, right? So if this is the first item in the list, what are we doing? Set head equal to current next, and then delete current. Sorry, I used the wrong kind of thing there. All right. Hope the comments didn't make it harder to read. Sometimes when you add too many comments, it makes it harder to read. I think we're good to go. Okay. So I could go and find some code for deleting it, an animation for it, but I hope you're able to visualize it based on that. I liked that one for adding though. Okay, so we called delete, but we don't have any debug print statements to see what it's doing. But we called delete on 7 and it did in fact delete it, right? So that code is good, but we better delete 5 as well and 200 as well to make sure that deleting at the beginning and the end doesn't break it, right? We need to test all those cases. So why don't we do that? We are going to delete, remove, that's the correct term. Scroll down to main. We've removed 7. Let's remove 5, the first one. plist remove 5. And plist remove 100. just to make sure it works. And then we add a 200. So the only thing we should see left are 6 and 200 because we have removed these guys. Do we feel like adding a debug print statement to remove, saying that we did so? Yeah, let's do that. And we could even call it with invalid data. That'd be a good idea as well, right? Just to prove that it works. Okay. So let's add a cout debug remove data equals, right, data ENDL. Or maybe we don't even need the ENDL, and our next print statement will pick it up. But let's put a space there just to make it look nice. So down here, once we find it, great. We might print that we did not find the data. Else we're going to print that we deleted the first item, right? Cout deleted first item. Else we're going to print out deleted subsequent item. Doesn't matter if it's the last item, right? Because we're just copying the last item's next into the prior values next. And if the last item's next is null, great. Works great. Guess I could be calling these nodes rather than items, right? And this one said this did not find node with data equal, right? Like that. All right, so scroll up, see what our output looked like, right? We removed 7, so that's in the middle of the list. Maybe I should make the word middle rather than subsequent, but it could also be at the end, so I kind of like subsequent. Then we deleted the first node. Then we deleted a subsequent one, which happened to be the end. And then we added 200, and when we printed it out, 6 and 200. So it still seems to be working correctly. The last thing to do would be, I mean, if we're not going to add any insert code, and I think I'm okay with not inserting. I might want to play an animation showing an insert. Otherwise, I think I'm okay without writing it so that we can move on and talk about other things. Scroll back down to main, and after we remove this stuff, let's remove something that doesn't exist, right? Remove data 8, did not find node with data 8. All right, I'm happy enough. The last couple of things you would want to add would be a find, which would return the pointer to the item that matched. And that would look very similar to the remove, right? Except it doesn't need to do as much, right? It just needs to find it, right? Or return null. So it needs to return a pointer to the list item, right? So it needs to return a pointer to a node. Whoops, already got that. And then we're going to call it find, and it's going to look for our piece of data. And we're going to have our usual code where node star current is equal to the header. We're going to keep going while current is not equal to null. If we find it, if current, this is going to be the easiest of all the loops, data is equal to the data passed in, then great, we found it. Return that pointer. Else we better go to the next one, right? Current is equal to current.next. That's like the easiest one of them all to find, to write, right? Very short. We're just stepping through the list until we find the one that matches our data. So why couldn't we use that one for delete as well? It's because it doesn't track the prior element. to get it to track the prior element as well as the current one, we'd have to like make it accept references or something, right? So that we could pass back some kind of data. You know, we could declare something called, you know, I don't want to do this. Prior, something like that, except make it a reference. But anyways, maybe you see why. Because in order to do a deletion, we need to know our current address, but we also need to know the last address, right? Or the prior one, the one we were looking at the time before. Okay, so let's add some comments. Find the node with the matching data and return its pointer. Like maybe you're going to change it, right? We could change, you know, 100 to 101. And removes that one. That one's pretty obvious, right? I don't like the way that comment wound up looking. Let's move the brace here. Okay. All right. Why not? Let's do it. Let's go down, and we deleted everything but 6 down in main. So let's find 6 and change it to a 7, right? So the node that we're looking for is equal to the lists find. Okay, great. I'm glad you did that, Anna. Just a second, I'll find it. And we're looking for 6. And if it's not null, if pfind is not equal to null, we're going to change it, that element's plist data, to 7, right? We're changing it. Oh, that needs to be an asterisk. Okay, there we go, right. And that needs to actually be done like that. And that needs to be pfind. I'll stare at it a little bit more, and then I'll go and look at the chat. I need to set myself up with a 2-monitor situation so that the chat is always on the screen. So anyways, we call find, and if it finds it, then its value is not equal to null, and we can use it to change its data, right? All right. 2 semicolons on line 42. All righty. Did I fix them? Let's go look. Aha. Yeah, good. In that particular case, it wouldn't hurt, right? But it looks stupid. So thank you for catching that. All right. To clean it up, I guess I could put that comment here, and I could remove the braces. Not strictly necessary, of course. Nothing wrong with too many braces. Sometimes I like to have a lot of braces. There we go. I don't know if that looks better or not. Anyways, I think we're good. I think we're good to go. Except, what if we get to here? It seems like if we get to here, we better return null. And I'm surprised this worked, right? Because there's no return statement. But yet we ran it and it worked. It did not complain that we did not have a return statement down here. But what would have happened if we tried to find, maybe I just never ran it. That's probably the case. Let's build it and get it a syntax error for not returning at the end of the statement. Oh, fine. It did work and it did change it to 7. But what if we'd look for an 8 or something that didn't exist? You see what's wrong? If we ever do find it, great. But if we don't find it, then we need to return null, right? That's the print statement, though. That's not helping us to look at. Why don't we, instead of doing a return current, why don't we say break? And then we can just return current down here and handle both cases. So current might be null because it never found it, or the list was empty. or current might equal, you know, one of the nodes. Yeah, I think that's going to work. Let's try it though. Let's do it both ways. We had a 7 down here in main where we were looking for 6 and replacing it with 7. Let's do the same thing. Let's look for 8 and change it to 7, but we know there's no 8. So this should do nothing, right? So we should not see a 9 in here, right? We changed our 6 to 7 because 6 really does exist, but there is no 8. So hopefully it won't crash. Find out. All right. And so the last time it printed, it did print 7, and there's no 9 in it. Did not find node with data equal 8. Oh, that's from the deletion, I think. But anyways, okay, I think we're good to go. I think we're good to go. Let's go find an animation for inserting into the linked list. I guess I could draw again. That might be enough. And I need to get the power cable. Okay, so annotate. What if you want to make a new one? What do you got to do? You got to allocate a new node, right? So we make a new node. You fill it in with the new data, right? So say we were inserting the value 77 in it. Good enough, right? I'm not going to worry about positioning it too well. And when we start off, its next pointer is null, right? Next pointer is null. And we look for the place to insert it, right? And eventually we set the next pointer equal to the memory address of the place that we were supposed to insert it. So with a while loop, we find the place where we want to insert it, like maybe this one. And if we're going to insert it, then his next becomes 525. Yeah, this looks sloppy. I should have used the text tool again, right? So his next becomes 525, but he doesn't need to point to 525 anymore. Instead, he needs to point to whatever memory address this was, like say it was 700, right? So we inserted a new item at memory address 700. We use a loop. We find it, the item at the position where we want to insert it before. Say we wanted to insert it before the 1. Then we find the 1. We use his next to fill in that one. Oh, his next was not 525. His next was 123. Yeah. We fill in with his current address. So his next reference is 525, and we change his next reference to point to 77. Hope that made no, to 700. We decided that that was the next item. That looks stupid, right? But oh well, just live with it because I don't know how to move it. All right, so anyways, that really should be 770. And then so we have this pointing to that one pointing to that one, right? So we've inserted it. Stop annotating. Linked list insert animation. That was pretty good. Who did this one? Maybe we can find somebody else by them. Technology Premiere. Linked list insert animation by the same people. Well, can't say that it leaped out. So why don't we just look for linked list insert animation? Inserting a node at the beginning, that's not really what I want, right? Maybe you get the idea. You get the idea, right? You just set your current next pointer to the one that you want to insert it before, and you set the last guy's next pointer to you. Yeah, let's just stop at that point. Somebody's, I don't know, let's look at this one. Oh, how nice, it's got music. So NQ is the same thing as append. Oh, this is only, since, all right, I'm gonna stop it right here. Because what is a queue? A queue is something where you only add to one end and you delete from the other, right? Like going into a line to get into the movie theater. You add items at the end of the theater. People stand in line at the end of the line, and then you remove them from the beginning of the line, right? And so a queue is not going to have an insert in the middle. It's just going to have an append and then a remove the first one. So let's call that a done lecture. I'm just going to add a comment about how you would write an insert and then not actually do it, right? So you would want to insert the new data, and then you would need a value for the data before, right? Look for the node that matches data before, right? If not found, nothing to insert, maybe do an append or whatever you want to do. So if not found, what are we going to do? Append? We insert, or do we just return an error? That's probably the right thing to do, right? Is if you say insert in front of Fred, but you can't find Fred, so you might want to just return an error, right? Something like that. Else, make the prior items next equal to the current. You'd have to allocate one, right, to the new node, and make the new node next equal to the found item address. Yeah, I hope that makes sense. All righty, we ready to move on to another topic? I hope so. If you watched the video, we talked about the idea of parent classes and child classes, or super classes and subclasses. What's the big idea about that? Well, so far we've been using classes to hold ISA data, right? Set up ISA, or excuse me, has a data. A node has a piece of data, right? And we could add as many pieces of data to a node as we wanted to, right? Like a patient has a first name and a last name and an address and an insurance information, all that stuff. Let's make a class that we can extend with a function, extra functionality, right? So we're going to make a base class. It's going to be kind of primitive, right? And then we're going to make a subclass of it that's got more powers. So the base class, and this is going to be a silly example. Just roll with it. Class, right? We're going to say that Pikachu evolves from something called Pichu, right? This is the root of the Pikachu line, because if you know your Pokemon, The baby one is called Pichu. And then when it evolves, it turns into Pikachu. And then when it evolves, it turns into Raichu, right? Okay, so, and if you don't know the idea of Pokemon, hopefully this will work anyways. All right, so what has Pichu got? Well, every Pokemon has a name, right? So let's just make a class Pokemon, which has got a name, right? So public string name, right? Or maybe we'd make a constructor that sets the name of it, right? So you could say Pokemon equals new Pokemon and you can pass in its name. So why don't we do that? We're going to make a constructor that accepts a name and sets that thing's name, right? So this arrow name is equal to the name string that was passed in. So down in main, if we want to create a Pokemon, pretty easy to do. It'll just look like this. I'll move this down to main in a minute, right? We would just create Pokemon star P is equal to new Pokemon, right? And pass in what we were going to call it, right? This Pokemon's called Fred. I know, silly. Okay, so he doesn't have any powers. All he's got is a name. So we're going to make a Pokemon that extends, that is a subclass. And so Pichu, all he's got is one little wimpy attack. He's got Spark. And I'm just making these up. I don't know my Pokemon from a hole in the ground. So class Pichu inherits from Pokemon. It extends Pokemon. It needs a constructor too. And when it constructs, I'm going to have to look up the syntax for this, sorry. I will do so in just a second. It sets the name of the Pokemon equal to Pikachu. Let me go Google that. Calling base class constructor C++. And so here they have one called shape, and it has a constructor that accepts a height and a width, right? And then they're writing a rectangle, which is a shape. And it needs to call the original constructor with the height and width passed into it. That's not too bad syntax, right? You just put a colon there. It's different in Java, but it's not too different. You just use a keyword called super, meaning superclass. Okay, so when we call Pichu, whoops, this is a constructor and it has to have the same name as the class we're currently in. Then it calls the Pokemon's class with the name Pikachu, right? It's Pichu, right? That's if you don't give it a name. If you do give it a name as you're creating it, then it needs to set its name equal to what you just passed in, right? So it needs to take a string name variable and set its name equal to that. So it's going to call his constructor with that information. Otherwise, it's just going to create one called Pichu, right? Now, what does a Pichu have? It's got a spark attack. So all of these are going to need to be made public, and it's going to have a spark attack, right? So void spark. See out Pichu sparks, right? Or maybe the name. This thing's name, spark attacks. So a Pichu can spark, but we're going to make a Pikachu with a different attack, Thunder Shock. Pikachu is more powerful than Pichu. Once you evolve Pichu, so we're going to make one called Pikachu, and every Pikachu is a Pichu, right? Except it's an evolved version. And so he needs a constructor. And his constructor, we could probably do this with default values. I'm going to try that. Pikachu string name is equal to Pikachu, right? So if you don't specify a name, it gets a default name. I think we've talked about that. When you write a function or a method, you can assign a default value to a parameter variable. And then we could call Pichu's constructor with that value. He doesn't like that. Well, I thought we wrote a constructor that accepted a string name. I'm going to try to get rid of this one. I can recreate it if I need to, but I'm going to make him have a default name of Pichu. It is public. We have a constructor that accepts a string. So this one should not be a compilation error. He really doesn't like that. But that syntax worked here. Okay, fine. We will make a default constructor and then we'll just set his name afterwards, right? So I'm going to undo that deletion that I just did. Stop it. All right, so we still have a default constructor. It's just going to call Pokemon and set its name to Pichu. But tell you what, why don't we just call the default constructor here? You can give it no name whatsoever. I'm not sure if that's going to work. I should modify this and have a default constructor as well, right? Because we have a custom constructor that accepts a name, but we need a default constructor as well, right? That doesn't accept any arguments. And it sets this thing's name equal to just default, right? Or Pokemon. So down here, when we create our Pokemon, after we do it, then we can call, right? We can just set his name equal to Pichu if we did not pass in a name like Fred, something silly like that. Otherwise, I really would like to keep it like that because it worked in this case. Expected a semicolon. Oh, I put the semicolon in the wrong place. All right. But following this example, I'm going to go ahead and do it that way, right? This thing's name is equal to the name that was passed in. Calling the constructor didn't work there, and I don't want to spend time figuring, I mean, it worked fine here, but it did not work fine here. So here we could create our Pokemon, and after we do so, we could set his name equal to the name that was passed in, right? But he's going to have an extra attack. And I know what's going on now. I made name. No, name is public, so we ought to be able to get a hold of it. We were able to get to it inside Pichu to Pokemon. But in this one, where we are extending the Pokemon class, maybe I should just stop and give up with the 2 level of inheritance, but I thought that this was going to work. This thing's name is equal to the name that we're passing in. Now, why are you complaining? Because we do have a name. Pikachu has no member name. Well, no kidding. It's because Pichu is supposed to have a member name, which it inherits from Pokemon. I'm going to abort on that because it's not working well. So what we're going to do instead is we're going to give this thing Pokemon. We're going to rename it Pichu, right? No, that's too much. We're going to give every Pokemon some specific thing, right? Something that might return its hit points, right? So every one of these things has a hit points. A generic Pokemon starts off with 50 hit points. And if we call get hit points, right, or get health or something like that, it returns that value. Now, since I'm going to rename him Pikachu, because if we can't get our multi-levels to work, then I'm just going to leave it like that, right? And so Pikachu is a Pokemon. I think we could probably get away with having multiple constructors if we just use this one. Get rid of that. We give him a name parameter that's got a default value in it, right? And if we get a name, whoops, forgot the word string there. If we get a name, we're going to set his name equal to that. So we don't need this because he was initialized with that. And this call right here calls this constructor, right, to set the name. And so we don't need duplicate constructors if we have a default value here, right? It's okay to call them with no value, but otherwise we will call them with a value. Okay, so every Pokemon has a get HP, but this guy needs an attack method, right? And he's got one. He's got one called Spark. Now we're going to make a different Pokemon, water Pokemon, right? Bulbasaur, or no, that's a grass Pokemon or something like that. I don't know. Charmander, a fire Pokemon. He is a Pokemon as well, right? And so he needs a constructor, right? It needs to be public. We're going to let them specify a name for him, right? His constructor will call the base class's constructor, right? To set it equal to that name that was passed in. And let's just see out a silly message, right? See out name, comma, I choose you, right? And we'll say that he's a Pikachu, right? Just so that we can differentiate the messages. And his constructor is going to see out a message as well, right? Except it's going to say that he's a Charmander in case we give it a custom name. Charmander has an attack. You can just call it burn because he's a fire thing. So void burn, right? And it prints out burn attacks, right? So let's go and create some Pokemon, right? So down in main, way down in main, that's why we should put that stuff in its own header file, right? Pokemon star P is equal to new Pokemon, right? It's just a generic Pokemon. And then C out, P's health equals that Pokemon's get hit points, right? Now let's make a Pikachu. Star Pika is equal to new Pikachu. So let's give him a custom name, right? We're just going to call him Pika. There we go. And we're going to say that Pika's health, and I'm getting an error there. I'll try to research why in just a second, equals, followed by his get hit points, Pika arrow, get hit points, but then he's going to call his attack just to prove it that he can, right? This Pokemon can't attack. He didn't have any attacks. It was only Charmander and Pikachu that had attacks. So Charmander and Pikachu each have everything that the class they inherit from has. So since the Pokemon class has a get HP, so does the Pikachu class. Now what's this complaint? Conversion to inaccessible base class not allowed. All right, now I get what's going on. I forgot that if we're going to inherit from a class, we need to say that we inherit our public methods, that whatever we inherit is public. That should make that error go away. And as a matter of fact, it did. I don't see the red there. And I can probably make a Raichu that inherits from Pikachu in the same way that I was trying to do before, right? Class Raichu, public Pikachu, right? He needs a constructor. So let's make a public constructor. Which accepts a name. And when it gets a name, it calls the Pikachu's constructor. So Pikachu, with that name. He doesn't like that. I'm missing a semicolon somewhere. Oh, public colon. Sorry, that's Java syntax to leave the colon off. There we go, right? And when we construct a Raichu, we're going to say, I choose you, but we're going to add our little comment saying that it's a Raichu. Where did Raichu go? Poor old Pichu, his data is completely gone. That's all right. All right. And he needs a special attack too. He's got everything Pikachu's got, but he's going to have Thunder Shock as well, right? Why don't I just copy one of these things and change its values? Okay. So we're going to create several different Pokemon, and we're going to add a pause statement between each one. So down in main, right? We've created the basic Pokemon, and then let's just system pause. And then we're going to create a Pika, and we're going to do an attack with it, right? So Pika's, he doesn't seem to have the attack that I was expecting. I don't see the spark attack that I was expecting, right? He should be able to do that, and I don't see it available. It says that Pokemon has no, oh, that's because I put the word Pokemon here. But it's true, right? A Pikachu is a Pokemon, but really, I'm going to do that, right? Because Pokemon doesn't know about the members of the subclasses of the child classes, right? They have extra powers, but the base class doesn't know about the extra powers. All right, so that'll work. And now let's make a Raichu, which has got similar stuff, right? Raichu star Raichu is equal to new Raichu. Let's not give him a custom name, right? That name's good enough. And then Raichu is going to do a spark because he can, right? Because he's got everything that Pikachu's got, and he's got more. He's got Thunder Shock as well. And I forgot to call, you know, the health function on it. Let me just copy this one and paste it. Right, so Raichu's health is that. All right, and then Charmander. I'll tell you what I'm gonna do. I'm just gonna copy and paste all of this because it would be easy to do that, right? And we're gonna call him Char. No, that's a bad name. Charmy. Okay. And Charmy's health is that. And he doesn't have a spark attack or a thunder shock attack. He's got his own business, right? Charmy has a, oh, my mistake is I forgot to change this one, right? Charmy is not a Raichu. Charmy is a Charmander. And now Charmy's going to have that burn attack. Charmander cannot be used to initialize an entity of type Raichu. See there, I declared him as the wrong type. I was being sloppy. I should not have even bothered cutting and pasting. Charmander, Charmy equals new Charmander. Charmy's health is this. It's saying that get HP is inaccessible. So I'm going to just blow off the idea of doing the double inheritance, right? Oh, see, I forgot to make him a public, just like the other one. Okay, so yeah, the Raichu one is working correctly. And I just botched this one because I forgot to make the public members of the Pokemon class public from Charmander. So now I should be able to come down here. I see a chat message coming up. That still didn't work. Yep, that fixed it. And he doesn't have Spark or Thunder Shock. He's got Burn. And we're going to call system pause each time, and I'm going to check the chat message. Vice versa, Andrew. You don't want to make a more specific kind of thing a base class pointer, right? Because what if Pikachu had extra things? And what do I mean by that? What if not only, now my knowledge of Pikachu's is going down the hill. Maybe I should, how about I wait and answer that one for my next example, right? And because I'm going to do a circle and a sphere next. Let me see if this one works. And then let me do the circle sphere. And then that should answer your current question. All right, so Pikachu's health is 50. That's a generic Pokemon, right? It doesn't have anything else except for the get health call. But we created a Pikachu, right? Pika, I choose you, Pikachu. And he has a health of 50. I guess all Pokemon have a health of 50. And he spark attacks. The next one, we built a Raichu. But Raichu is a Pikachu, right? Plus more. So his constructor calls the Pikachu's constructor, and then he finishes running with the Raichu constructor. So he does everything that Pikachu do plus his own custom behavior. And so he has the spark attack that a Pikachu has, and he's also got his own special attack, Thundershock. And now here comes Charmander. Charmander, I choose you, right? All of them have a health call, so that works, but he doesn't have a shock, right? Or, you know, a Thundershock or Spark. He's got his own attack. Okay, so to answer your question before I do the other example, if I do this, I mean, let's try the syntax and see if it gets us an error message that makes sense to us. If I'm going to make a Raichu is equal to new Pokemon, right, like that, and give it a good name, it's going to complain about it. It's saying a value of type Pokemon cannot be used to initialize an entity of type Raichu. You can store a pointer to any child class and a pointer of the base class, but not vice versa. So that's not going to work. Can't do that. How about I spell correctly? So this is an error, but it's okay to do the opposite, right? We could say Pokemon R2 is equal to new Raichu. The only problem with that, whoops, is not liking that. No suitable constructor exists to convert Raichu to Pokemon. I thought that was going to work. It seemed like it worked up earlier. Oh, because I forgot to put an asterisk in front of it. There we go, right? So this constructed a Raichu. Now, inheritance doesn't do an is-a relationship. A Pokemon, excuse me, vice versa. Inheritance sets up a has-a relationship, right? Let's do is-a relationship. It's a me, Mario. All right, so is-a versus has-a. Members are has-a. Sounds silly, right? Every Pokemon has a name, right? Every node has a data. But an is-a, right? A Pikachu is a Pokemon because this is the base class and that's the inherited class. And a Raichu is a Pikachu, which is a, right? Pokemon. And then a Charmander also is a Pokemon, right? So inheritance sets up an is-a relationship. And so you can store a reference to a Raichu or a Charmander into a Pokemon pointer, right? Any of these types will fit into a Pokemon pointer. And a Raichu will fit into a Pikachu pointer. because a Raichu is a Pikachu, just with more. But the problem becomes then, what if you want to access the sub elements, right? The child elements. So down here where I made this thing, R2, and I said that he was a Raichu, I'm going to call that P2 instead. P2 doesn't know it's a Raichu. All it knows is that it's a Pokemon, right? Because if we did this, we separated it in two things, right? P2 is equal to new Raichu. We can call Pokemon methods, right? We can do P2.getHP, but we can't do anything else. We can't do Raichu or Pikachu's because we don't have a pointer to a Raichu. We only have a pointer to a Pokemon. But you can cast it, right? You could say Raichu star R2 is equal to static underscore cast, and there's other ways of casting as well, right? We've talked about this. To the form of a Raichu, our P2 pointer. And that looks like it's giving us an error. No suitable constructor exists to convert a Pikachu pointer to a Raichu pointer. Well, I'm not going to go into it further then. I'm just going to accept that you ought to be able to convert it, and I'm not getting that to work. It's going to give me the same error. It doesn't know how to convert my Pikachu pointer to a Raichu pointer. And that's my Pokemon pointer to a Raichu pointer. That's too bad. But I hope it makes sense why we could not do the syntax that you suggested, right? Because if you create a more generic object, then it doesn't have the information, enough information to consider it a Raichu. Okay, yeah, okay, cool. You already explained, and I spent longer talking about it, but let's pretend that was for the benefit of everybody else. All right. One more example. A sphere class and a circle class. A sphere is a circle that has a third dimension, right? Or we could make a rectangle that has a third condition, right, to make it a block. So we're going to make a circle class. And every circle has a radius, right? We're going to go whole hog here. We're going to give it a radius, but we're going to make it private. We're going to initialize it to 0, but its constructor is going to set it equal to the value that's passed in, right? So we need a circle which accepts a radius, and we can set this radius equal to radius, right? And then we're going to make a sphere class. Since this value is private, nobody else could use it except for the circle class. Even child classes won't be able to use it. So we're going to have to make a change in a minute to get that to work, for the sphere class to know that it has a radius because it's private. Everybody knew about their name in the Pokemon hierarchy because name was public. But this is private, so even sphere can't get a hold of it. So we're going to make a constructor here that takes a radius, and it calls the root class's constructor, the base class's constructor. Every class is a public circle, right? And so we can call the circles constructor with the radius that was passed in. We can see out, circle constructed. We can call out, sphere constructed. All right, so what do we care about spheres? Excuse me, circles. We want to know their area. So we're going to make something called get area. which calculates and returns the area, right? Double A is equal to pi r squared, right? 3.14159 times this POW, right? Or how about just this thing's radius times this thing's radius? I should use POW, but I'd have to go back if I was a Mac user and add all the other defines, right? But since I'm using Windows, it lets me go ahead and do it like this, right? We're going to use this guy's radius, and you could leave off this keyword as long as there's no name conflict between the name of the parameter and the name of the member variable. And we're going to raise him to the power of 2, and we're going to return that value. All right, so that's get area. The area of a circle, the surface area of a sphere is different though, right? Let's Google up surface area sphere, get the formula. Thank you, Google. It's 4 pi r squared. Oh, I could probably just call pi r squared and multiply by 4, right? So let's do that. Nah, I'm not going to just do that because I don't remember how to call these ones. So I forgot to make this public. It needs to be public or else we couldn't construct it. So public, wait, no, we don't need to use that keyword twice, unlike Java. So double get area, and it's going to return 4 pi r squared, right? Now here's what I think I could do. Well, see, here's the problem. I can't call this, I can't get a hold of radius because radius is defined as private. I can fix that though by making it protected. Protected means make it private to circle. Oh, that's not a real keyword. All right, must be forgetting my languages there. I'm going to write a get area, a get radius method that'll return that, right? So public double get radius returns a radius. Don't need that keyword. You don't repeat it. Keep doing that. That's Java syntax. All right. I like to have the constructor as the top method of the class, so I'm going to cut that and move it down to get area. So that's what our circle class looks like, right? It's got a get radius method, it's got a get area method, and it's got a constructor. And its only member variable is radius. So sphere needs to call get radius in order to get a hold of that, right? So it could call get radius, and it has access to the variable that way. Now here's what I'm wondering is can I do this? Can I do return 4 times and then say, well, I know it's a circle. You know, that's what I was doing wrong when I was trying to do my conversion. I forgot to put the asterisk when I was trying to do that cast. Let's do that. We're going to pretend we're going to set ourselves up a circle pointer to a circle, and it's equal to the circle version of the this reference. So now we have a way to access the root members, right? We can call get area on him. So return 4 times PC's get radius, get area. That makes sense? That's how I get a hold of this area for this method, right? Because I got to treat it as a circle to get a hold of this, or I have to give them different names, right? One or the other. Now there's a way around that, but I'm not going to talk about it. I think that this is a good enough example, right? we need to access this, so we could do that. And if you wanted to, I wouldn't do this, but you could take this and put that there inside parentheses. And the syntax looks a little bit weird, but that would work. I don't know. Do you like the syntax? I need to treat myself like a circle before I can call get area. Maybe that's good syntax. You know, or static cast myself to be a circle star, right? If we did it like that, would it look good? Static underscore cast, parentheses circle. Excuse me, use my angles there. This, right? If we do that, could we even get rid of these? All right. The syntax looks kind of nasty, right? Maybe you liked it the way it was before. Return 4 times the circle things, get area, right? So you could do it. I'm going to use the word reference, but that's not the correct term, of course. We know that a reference means something else. You could do it via reference to it as a circle here, or you could embed all that right there, right? I think that kind of makes it look horrible. I'd kind of rather do it like that, but you could do it either way. All right, so we can go down to main and create a sphere and calculate his area, and we can create a circle and calculate his area, and one should be 4 times as large as the other. So down in good old main, or way down in good old main, here we go. All righty, system pause. And we're getting close to the time when we need to end, aren't we? Anyways, I'm going to make a circle. P-circ is equal to new circle with a radius of 10. And then C out radius, excuse me, area of circle is followed by P-circs, arrow, get area, right? Parentheses in parentheses, ENDL. Now let's make a sphere. Sphere star P-sphere equals new sphere of 10. Uppercase P needs to be a lowercase p, right? And then I'm just going to copy and paste this, right, because I can make a few changes. I always say that and then get into trouble, but let's try it. The area of the sphere is equal to P sphere get area, right? But we're going to add a method to the sphere, right? It's a 3-dimensional object, so it has get volume. So I'm going to go back and find my sphere class, and I'm going to add a new method to it. And the volume of a sphere, I believe, is 4/3 pi r cubed, right? So double get volume, you know, double R, the result is equal to, or V for volume, is equal to 4.0 divided by 3.0 times pi 3.14159 times POW of get underscore radius to the power of 3, and then return that, right? I guess I didn't do this the way that I did it the other time, right? Double A for area is equal to that, and then return A. Doesn't matter. You can do it the same. You can calculate it and return it in one statement, or you can calculate it and then return it in the following statement. All right, so there we go. So every sphere has a volume, so we can get the volume of the sphere, but we can't get the volume of the circle. Way down in Maine. Too far. So add one more. C out, volume of sphere is P sphere, arrow, get underscore volume, and I misspelled that, NDL. Okay. But if we tried to call get volume on circle, we can't, right? Because we added it to the sphere class. A sphere is a circle. A circle has an area. A sphere has an area, but it also has a volume. And only volume exists, right, for sphere. Volume only exists for sphere. I'm not going to even type in pcirc get volume. It would be a syntax error. There's no reason to do that. Let's see if it works. Make sure it compiles. Right? Okay, there we go. So the area of a circle is that. The area of a sphere is 4 times that, and its volume is, larger still. Then if we hit return, it starts doing all the other stuff. All right, so that's our introduction to inheritance. There are other concepts to learn. There's the idea of abstract classes. There's the idea of method overriding, which we did. Let me call out to where we did that. When we had our sphere class right here, this is an override of get area, right? It overrides the circle class, get area. It replaces it, right? So that on our sphere class, when we call get area, it runs this code. It doesn't run the other one. So override means replace, right? Different than overloading, which is when you have 2 different methods with the same name but different parameters. Overriding is when you have 2 different methods with the same parameters but in different classes. In the root class and the child class, the base class, and the superclass or the subclass, whatever terminology we want to use. All right, you could learn a lot more about object-oriented programming and inheritance and stuff like that if you take advanced Java. And for those of y'all who, have gotten this stuff pretty well and you know how to make a class, I don't even think I assigned a class assignment, although I should have. And one idea I had is to have y'all create, a class in class, no pun intended, but I took up too much of our lecture time to do that. So I hope you have the idea of a class. We've had several examples as we go along. If any of y'all want to, if you do not have to have beginning Java as part of your degree program, but you want to learn more about programming, take the Advanced Java course. And the reason I say take the Advanced Java is knowing what you know right now. Understanding arrays and understanding classes and stuff like that, you already know enough about Java to pass the basic class, pretty much, right? Because Java is the same as C++, just a little different. And there's no reason for you to take another course that teaches you what a for loop is, right? Or what an if statement is, or what a while statement is. And beginning Java covers all that stuff, right? But advanced Java covers cooler stuff, the same kind of things if we offered an advanced C++ course, but we do not. So beginning Java is a prereq for advanced Java. But if you did well in this class, then I'm going to know that you're ready for advanced Java. And I would tell the advisor to let you in anyways, right? I'd give you a pass. You'd be able to take the advanced Java. And it's offered in the fall. You might consider taking it. I think it's taught as a lecture as well as online. I have no idea how everything's going to play out with COVID and all of that. But even if it's a lecture class, you can take it like it's an online class, right? I'll record all the lectures. What are they called? They gave them a special term for the upcoming semester, Flex. meaning that you can do it at home or you can do it in a lecture. So if you feel like going on campus and wearing a mask, you could sit through the lecture. If you want to stay at home and be safe, then you could do it that way. So that's the next step I would recommend as far as a programming course goes. Or take scripting, right? If you're in the cyber program here, then you're going to learn scripting anyways. The Python language is really cool. Everybody who takes it really winds up liking it. Quite often they wind up liking it more than C++ and Java. It's a cool language. And if you're taking this to get credit to go somewhere else, then I don't know if you need Python. You'd have to look at your degree program, you know, for UCO or whatever. All right, gang. So what are we going to do about the exam? I think that we have a folder. An assignment. Where was that? Exam, skipping it, right? So let's add that to week 8, right? Just go to week 8, click on that, and if you haven't already, do so, right? And just put a submission here, right? Say that you were here for the lecture. I will post the notes for this, but you don't need to create a lecture review form for it. Maybe I probably ought to should. I will. I'm going to do that just so that you know that you did it. But I also want you to fill in that exam thing, right? And then you'll get your super high grade on the exam. And those who didn't, we're just going to have to arrange for you to have taken it by Monday morning. So for those of y'all who watch this later, contact me and we'll set that up. All righty. Any questions? Any questions? I hope y'all have learned a lot. Everything should be graded by, tomorrow evening, so you can go in and check your grade. I can accept stuff up through the end of Sunday, right? But grades have to be turned in Monday morning. So if you've been holding off on getting a homework assignment done, or you want to do a couple more lectures, get them done by Sunday, okay? Yes, I'm going to make a lecture box for this. So, a folder for this. So please go ahead and do the lecture review. All right. I'll do that as soon as we stop the lecture. Y'all are a great class. I hope to see you in future classes. And yes, indeed, I'm going to upload the lecture. And I'll upload the notes. In fact, I'll post them here like I usually do for you. So just a second. I'm going to stop the recording now. We don't need to keep recording this.